Hi, today I'm going to be discussing the task 8.1c, lambda expressions and generics. So first we will take a look at this code. This is my code for the MyStackT class, and then I have the account class and the tester class to test the MyStack's classes methods. Now, if we first talk about what generics is, generics gives us a way to parameterize the data types used within a class or a method. This allows us to create data structures that work with any data type. So in my code, we have used this MyStackT class that uses generics, where T is a placeholder for any data type. This means that we can create a stack of integers, strings, or custom objects like account. Now, if we talk about how we are using generics within this implementation, we are using generics for all the methods given in this class. Now, the class MyStackT is also using generics to define a stack data structure that can hold elements of any type. Here, T is the placeholder for that type that will be used in the stack. And this allows the stack to be more flexible in storing different types of data, such as int, it can be double, or a custom type like account. Then we have the methods in MyStackT. We have the push, pop, find method, then find all method, remove all, the max method, and min method. All these methods are using the type T because it's in the MyStackT class. So the operations like the push, pop, find all, remove all, max, and min are applicable to any type that MyStackT is instantiated with. Then these methods are written only once. As you can see, we have the pop, find all, remove all, and these functions written only once. We don't have those methods written in these classes or within the tester class. That means that we can reuse the code regardless of the type of objects that's being handled. This ensures type safety, and it eliminates the need to write type-specific versions for each method. Now we have the find all and remove all methods. They are using delegates, which is the func tbool. As you can see, we have for the find, we have func tbool, and then we have for find all, then we have for remove all as well. This applies the search and filter criteria. This uses the power of generics to apply different predicates without depending on a specific type. For example, if we take the find method, we can use the find method to find the account based on a criteria like a balance that's bigger than 100, or we can find a integer that's satisfying another different condition. Now, if we talk about the minimum and maximum methods, that's called max and min. These two methods are using the comparator class. This comparator class is used to find the minimum and maximum values in the stack. Generics makes it possible to use these methods with different data types without using specific comparison logic for each one, because we're using comparator here and here. Now, what are the benefits of using generics? Generics improve the code reusability. As I said earlier, we don't have to write the same code again and again because we're using generics. In this program, we're using the MyStackT class that can be used to create stacks for any data type, from simple types like int to double, or complex types like account. This avoids code duplication and makes it much easier for us to create reusable data structures. And using generics also makes it flexible because we are using a func tbool here, a delegate in methods like find and find all, and this allows us to define custom search or filter criteria, which can be used with any type given in the type T. This improves the flexibility of operations performed on the stack. Then we have reduced the code complexity because we are using generics. Without generics, we would have to create a new class for each type of stacks because we might need to create an int stack or string stack or count stack for this program. But with the use of generics, we have reduced the code complexity by creating a single class called MyStackT. And this class can be used for any data type. So this reduces the complexity by heaps. So those are few of the main benefits we get from using generics with our implementation. So now we can take a look at the account class. We have the compare to function so that we can find the minimum and maximum. Then we have the tester class that writes a few tests to check if all the methods are working as expected. Now we can try to run the code and see if it works as expected. As you can see, our program is working, that it's finding an account with balance 1,000, and it's also testing the find all method. Then it's testing the remove all method by removing accounts with negative balances and by removing accounts with starting with S. So, and it's also testing for null criteria. It's testing if it's throwing the argument null exception as expected. And we have testing edge cases so that it's not gonna try to run this code for empty stacks. And so that's all for my program. And as you can see, it's working as expected. Thank you for watching.